Hello guys, welcome to my channel. In this video, we are going to discuss about microservices. We will understand what are microservices. We will see microservices architecture and we will discuss advantages, use cases, along with comparing the microservices architecture with monolithic architecture. Okay, let's begin the video. Let me start by explaining the microservices. What are microservices? If you see the definition here, a software architectural style where applications are structured as a collection of small, loosely coupled services. That means you can create one application, or if you have one large application, we can or you can create that application with multiple microservices. Basically, you can deploy or you can divide application in different parts and you can develop them as microservices, okay, separately. So there will be a small service or a small part of application and they will be loosely coupled so that whenever you create one service, that is, or there is no dependency of that microservice with another one. Okay, each service focuses on a specific business capability. All the microservices will have different functionality and they will be interconnected with each other with the API gateway, and they will be working, and they will finally, after deploying all the microservices, they will finally just uh, develop, or you can say build an whole application. These are some of the characteristics of microservices, like independently deployable. You can deploy the application without depending to each other. That means if you have suppose 10 microservices, you can deploy the 10 of them or you can deploy any one of them at one time. They are not dependent on each other. Okay, these are scalable. You can scale the microservices whenever you want, and they are isolated from one another, so that if one microservices goes down, all the others will be up and running, so that your application functionality will be still working. Only the functionality which is down microservices has been supporting will not work. Let's see the microservices versus monolithic application architecture. Okay, so if you see the monolithic architecture, this is single and unified code base. You will have code for all the application or the whole application in one repository, and you will have to code everything inside just one repository and for the application. Components are tightly integrated. All components of your application will be tightly integrated. That means if something goes down or something breaks, whole application will break down and your application will not work. But in case of microservices, this is decentralized components. You can see, if this is microservices, these are 5 microservices and they are forming one application. Okay, so they are all decentralized. Services can operate independently. So one service, suppose this is one service, this box, this can operate independently. They are not dependent on each other. So if one of them goes down, other four will still be active and they will still be working. Okay, that's why they are independent and they can be deployed automatically, individually, independently, or they can be scaled independently, they can be deleted independently, and they can be developed independently. Okay, so this is the advantage we get if we compare monolithic architecture application with the microservices one. You can divide your whole application into the multiple microservices, and you can develop different microservices independently by the different development teams with different languages as well. Okay, let's go ahead. Let me discuss some of the components of microservices architecture. The first one is the services. Services is nothing but the, you can say, the small part of your application. These are independent modular units focused on specific functionalities. Okay, so suppose you have one or you have created one application microservice just to support your email functionality of application. Okay, so that can be one service or one part of your application, that is called service or microservices. Second one is API gateway. This facilitates communication between services and clients. So the microservice will be able to communicate with the clients with the API gateway. Generally, API gateway will be created and supplied by your cloud provider. If you take an example, you can take the example of API management in Azure. The next one is service discovery. This helps in locating other services. Okay, you can locate all other services, all other microservices inside your application. Database per service. Each microservice manage its own database so that they are not dependent, or even their database is not dependent. If something goes down for or some database issue for one particular service, only that microservice will be affected because they are managing their own database. Communication. Generally, microservices communicate with HTTP. You can see synchronous HTTP REST and asynchronous messages queues like Kafka. You can see the diagram here. This is the basic microservices architecture. There will be client and API gateway will be in there in between the microservices. This whole part is microservice. Inside the microservices architecture, you can see there are multiple service available here. Okay, so this service will support different functionality, this one will support different one, and this one will support the different one, and they all will be communicating with client with the API gateway. And after just form or after merging all these four, one of the microservice architecture will be created and your application will be created. These are some of the key concepts in microservices. Service independence. Each microservice can be built, deployed, and scaled independently, like we already discussed. Different or one of the development team can focus on one microservice, and another development team can focus on another one. Suppose you have five microservices, then five development teams can manage the five microservices so that they can be developed in parallel, they can be even deployed in parallel, and they can be tested in parallel. So this will save the time as well, so that your release will be frequently and it will fast just it will help fast your release cycle. Okay, loose coupling. Microservices are loosely coupled. Services are loosely coupled and interact through APIs. Okay, all the application or all the microservices will be interacting with help of the APIs. Okay, polyglot programming. Each service can use a different tech stack. That means you can use different technologies to develop different microservices. Suppose you have one microservices and you want to use Java for that, you can use Java. If you want to use different programming language as well for different microservice, you can use the same. So this is the advantage we get in case of microservices. Continuous delivery, isolated in development for easier and faster delivery cycle. Okay, so this the development can be isolated, like I said, all the microservices can be developed independently and they will be deployed independently as well. So since there is no dependency, this will just make the development easier and let you deliver your code faster. Okay, or it will just fast you can just fasten your deployment release cycle. Let's discuss some of the advantages of microservices. First one is scalability. Ability to scale services independently. You will be able to scale any of the service independently without affecting the another one. Okay, so this is the advantage we get in the microservices. Resilience. Failure in one service doesn't affect others. So even if your one microservice has been failed or corrupted or there is some issue inside that, other microservices will not be affected because of this. Okay. The third one is faster development. Teams can work on separate services independently, like we already discussed. Different development teams can work together or can work can work on separate services independently. Okay, so that this will make the application development faster because multiple teams and multiple people are working to develop the microservices and finally the application. Okay, you can see different services can use different technologies. In case of microservice, this is one of the advantages of using microservices. If you have some requirement like this functionality should be you working with this one, or this functionality can be achieved by another one, so you can use different technologies as well to develop the microservices. The last one is improved fault isolation. Issues in one service don't affect the entire system. Like we already discussed, even if we get one issue or any issue inside your one microservice, this will just affect that particular microservice only. This will not affect the entire system. Okay, so that your application will not go down and it will still be accessible to your users. Okay, we discussed everything. We discussed the architecture, benefits, advantages. Let's discuss the some of the challenges which we might get using the microservices. The first one is increased complexity. Since we are using or managing multiple services, this will increase the operational complexity. Okay, it will of course need the high professional or highly skilled professional to manage all the microservices and design them. Distributed system issues, challenges with network latency, load balancing, and fault tolerance. Generally, even if you are able to communicate with APIs, you will get latency issues sometimes and related to load balancing and fault tolerance as well. The next one is data management, handling data consistency across services. Generally, you get this type of issue in the microservices. Security. Each service must be secured independently, so that you will have to work for the security of microservices independently. You will have to scan the code, source code independently, and you will have to manage that particular microservice independently. Okay, that microservice service is itself an application. You will have to treat that as an application. These are some of the use cases of microservices. Netflix, they scaled content streaming across millions of users using microservices. In case of Amazon, they are efficiently managing their e-commerce platform using the microservices. Uber, microservices for real-time tracking and ride management. E-commerce platforms are like for cart, payment, and recommendation engines as separate services. So these are some of the use cases of microservices. In today's world, most of the companies are now moving towards microservices because they can migrate and they can just run their large applications smoothly using the microservices. These are some of the best practices if you are using microservices. You need to design for failure. You will have to build your application with the expectation that this may fail. Okay. API contracts, define clear API contracts between the services. You'll have to write the APIs so that they will be able to communicate with the services easily. Okay. Containerization. Use Docker Kubernetes for service management. You can use the Docker Kubernetes and deploy that to the particular environment. Like if you are using the Kubernetes, you can deploy then them to Kubernetes, and even you can use or you can deploy a microservice into the Azure Service Fabric clusters. Next one is DevOps integration. You can automate testing, integration, and deployment using CI/CD pipelines. For CI/CD, you can use any of the CI/CD tools available like Jenkins, Azure DevOps, or any. others. Let's talk about the real world example of microservices. Okay, so in case of Netflix microservices architecture, they transition from a monolithic architecture to microservices. What are the benefits? Faster updates, increased reliability, easier scaling, and fault tolerance. How faster updates? Because different teams might be handling and developing the microservices independently. That's why they will be able to develop and deliver their microservice faster. Okay, the next one is increased reliability. Since you are using or they are using the microservices or suppose 10 microservices, even if one of them goes down, generally they don't, but even if one of them goes down, all other nines will be working fine and their application will not go down at once. Okay, easier scaling, they will be able to scale the applications easier, I mean easily. Let's conclude. We discussed everything about microservices. Microservices enable scalability, flexibility, and rapid development and deployment. This is best suited for large and complex applications. So if you have large and complex applications to develop, you can use the microservices architecture and you can deploy your or you can basically uh, divide your application in multiple microservices and you can develop them independently and you can even deploy them independently. The next one is that challenges include data management, network issues, and security. If you are using microservices, you will have to consider the challenges as well, like data management, network issues, and security. But these are minor challenges. If you have large and complex application, you can always go for the microservices architecture because this has lots of advantages. Okay, that's it from this video. If you liked it, please like and subscribe my channel. If you have any feedback, suggestions, or any questions, please let me know in the comments. Thanks for watching.